What if I told you there's a wall standing right now, today, in the middle of Istanbul that has survived cannon fire, earthquakes, and armies of 50,000 men camped at its base for weeks trying to tear it down? Not a wall made of steel, not modern reinforced concrete, a wall made of dirt, ash, and a handful of lime, and it is still standing after 1,600 years. Stick with me for the next 60 seconds, because what I am about to show you is going to completely change the way you think about construction, about history, and about what the modern building industry does not want you to figure out on your own. If you are new here at Hidden Life Hacks, this is exactly the kind of buried knowledge we dig up every single week. Hit that subscribe button right now and tap the bell so you never miss a vault when it opens. Let's go. Here's the part that should make your jaw drop. When a massive artillery cannon, the biggest siege weapon the medieval world had ever seen, fired a 600-pound stone ball directly at this wall for 53 straight days, the wall did not fall. The cannonball bounced. The city behind it only fell because a single small gate was accidentally left unlocked. The walls themselves? Never broken, never breached. A structure built from materials your grandfather could have found in his backyard survived the greatest weapon of its era without so much as a crack that could not heal itself. And I mean that literally. The wall healed its own cracks, on a chemical level. And the recipe that made that possible has been sitting in dirt, ash, and fire pits for over 9,000 years. The industry that replaced it is worth $1.8 trillion. And they have absolutely no interest in you knowing what I'm about to tell you. Now, let me take you back to where this story actually starts, because most people think ancient construction was primitive. Most people are completely wrong. Archaeologists working at sites in the Jordan Valley and in modern Syria pulled mortar samples from walls that were built before the wheel existed. Before written language had spread across the earth in any organized form. They ran those samples through modern laboratory equipment, X-ray diffraction, electron microscopy, and what they found stunned them. The chemical fingerprints inside that ancient mortar matched the exact same hardening reaction used in high-performance modern concrete. 9,000 years ago, builders in the Near East were burning plant material, firing clay into dust, and combining it with lime to create a cementing compound that would still be holding walls upright when the pyramids were just an idea someone had not drawn on paper yet. This was not luck. This was not primitive guesswork. These were people who had figured out through generations of trial and observation something that the modern construction industry spent $1 trillion trying to replace and still has not beaten in terms of durability. Now jump forward to ancient Rome, around the 3rd century before Christ. Roman engineers discovered a very specific type of volcanic dust near a town outside Naples. They called it pozzolana, and when they mixed that ash with slaked lime, water, and broken stone, something remarkable happened. The mixture hardened underwater. It set without sunlight. And it kept getting stronger for decades after it was poured. Not days, decades. The Roman architect Vitruvius wrote down the original recipe around 25 BC. 1 part lime to 3 parts pozzolana for above ground work, 1 to 2 for anything that had to live in seawater. Simple, exact, and devastatingly effective. The Romans used this formula to build the Pantheon in 128 AD. That building's unreinforced dome is still the largest of its kind on the planet nearly 1,900 years later. They built harbor walls at Caesarea Maritima that are still standing in the Mediterranean today. Meanwhile, modern marine concrete crumbles within a few decades of being poured. Think about that contrast for a moment. Modern concrete, with all of our advanced chemistry and industrial precision, does not outlast what Roman builders made with volcanic ash and lime mixed by hand. In 2023, researchers at MIT finally cracked the mystery of why Roman concrete refuses to die. The Romans were using a process called hot mixing. They embedded small chunks of unslaked lime directly into the wet mortar during construction. Over time, when a crack formed and water seeped in, those lime chunks dissolved. They reacted with the silica from the ash, and they physically filled the crack with new crystalline mineral. The wall repaired itself, not as a figure of speech, chemically. The material was designed to grow stronger around damage instead of failing because of it. I want you to stay with me here because this is where the story moves from fascinating to almost unbelievable. The Roman Empire eventually split. The eastern half became the Byzantine Empire with its capital at Constantinople on the Bosphorus. And in the early 5th century, under Emperor Theodosius II, they built a wall around that city that would become the most studied piece of military architecture in all of human history. 3 concentric rings of fortification, a moat, 96 towers, a total defensive depth of 70 meters. The inner wall stood 12 meters tall and 6 meters thick at its widest point. Builders today spend fortunes trying to achieve those specs with modern poured concrete and rebar. The Byzantines did it with fired brick dust, lime, river sand, and limestone aggregate mixed into a rammed earth core. Here's the thing. They did not have a volcano nearby like the Romans did. So they created their own pozzolanic material. They took fired clay bricks, ground them down into a coarse powder, and used that brick dust as an artificial additive. The science was the same. The chemistry was the same. The result was a mortar core that absorbed earthquakes, laughed at battering rams, and made some of the most powerful armies in history look completely helpless. The Avars hit those walls in 626. They failed. The Arabs tried in 674 and again in 717. They failed. The Bulgars, the Rus, the Sassanids, all of them broke against that wall. And then in 1453, Sultan Mehmed II arrived with 80,000 troops and a Hungarian engineer named Urban, who had built a cannon over 27 feet long that could throw a 600-pound stone ball. They called it the Basilica. They aimed it at the same gate for 53 days of continuous bombardment, and the wall still held. The city fell when an unlocked gate was discovered, and defenders, who were outnumbered 15-1, simply ran out of men to hold every position. But the walls themselves were never defeated. Now here is where the story takes a turn that directly affects you and your wallet right now in 2026. When Constantinople fell, Byzantine engineers and scholars fled west into Europe. Some reached Venice, some reached Florence. Their knowledge sparked what we now call the Renaissance. But the deep practical knowledge of how to build with lime, stabilized, rammed earth, and pozzolanic ash did not survive that journey into Western construction culture. Western Europe was already deep into stone and timber traditions. The technical understanding of ash, stabilized earth as a primary structural material, simply faded out of practice. It was not banned. It was not burned. It was not forbidden. It was just never passed down to the next generation in the new places these builders landed. By the time Joseph Aspdin patented Portland cement in England in 1824, the Theodosian recipe was already a footnote buried in archaeological surveys. Within 100 years, Portland cement had taken over global construction completely. And by 1930, the older formula was effectively gone from mainstream practice, and the industry that rose up around Portland cement had no motivation whatsoever to bring it back, because there is nothing to sell. The global cement market in 2025 was valued at over $475 billion. The global concrete market hit $1.8 trillion. That is not a rounding error. That is the actual number. The industry employs over 4 million people directly and another 10 million indirectly. It is one of the largest industrial sectors on Earth. And it is built on a single foundational assumption, that concrete is something you buy in a bag, pay to have mixed and poured, and eventually pay again to have repaired or replaced. Portland cement cures in 28 days. It reaches working strength fast. It ships in 50-pound bags from centralized factories. It generates revenue at every single step in the supply chain. Lime pozzolan rammed earth does none of that. The lime is cheap, the ash is free or close to free, the dirt is literally right underneath you. You mix it on site with hand tools or a small mechanical rammer. It cures slowly over months and sometimes years, still gaining strength the entire time. You cannot centralize it. You cannot truck it in and charge delivery fees. There is no patent to license. The chemistry is older than the alphabet, and you cannot trademark a reaction that ancient builders were using before written language existed. So the market simply forgot it. Or more accurately, the market paid billions to make sure you forgot it. Before I walk you through exactly how to mix this yourself, I need to tell you one more thing about what is happening at the molecular level, so you actually understand why this works and why it works better than what the modern industry sells you. Lime is calcium hydroxide. You start with limestone, which is calcium carbonate, and you cook it at around 1,000 degrees Celsius. The carbon dioxide burns off, and what remains is calcium oxide, which is also called quicklime. Add water, and that quicklime reacts violently and converts into calcium hydroxide, which is slaked lime. By itself, slaked lime hardens slowly by pulling carbon dioxide back out of the air in a process called carbonation. That alone gives you a usable mortar, but it stays relatively soft. The kind you find crumbling out of old colonial American brick walls when you press them with your thumb. Now bring ash into the picture. Specifically, any ash that is rich in silica and alumina. Volcanic ash is the strongest natural pozzolan, but it is far from the only one. A research paper published in Construction and Building Materials in 2019 tested wood ash directly as a pozzolanic additive in lime mortar. The results were specific and fully reproducible. At 20 to 40% wood ash content, lime mortar showed measurable increases in compressive strength, better hardening behavior, and improved performance in damp conditions compared to lime alone. The fine particles in the ash created what researchers described as a chemical handshake. The silicon dioxide and aluminum oxide in the burned plant material reacted with the calcium hydroxide in the lime, in the presence of water, and formed two new compounds: calcium silicate hydrate and calcium aluminate hydrate. These are the same crystalline structures that give modern Portland cement its strength. They are chemically insoluble. They lock onto surrounding aggregate at a molecular level, and they keep forming slowly for years after the wall is finished. Pack that lime ash binder into compressed subsoil with the right clay, silt, and sand ratios, and you get rammed earth. Modern engineering studies have measured this material under controlled laboratory conditions. A study at the University of Granada in 2022 tested lime stabilized rammed earth at multiple lime concentrations and found that 12% lime content maximized compressive strength and stiffness. The material continued to gain strength for over 100 days of curing. Other peer-reviewed work has measured cement stabilized rammed earth reaching 40 megapascals of compressive strength. That is equivalent to standard structural concrete. Lime pozzolan, rammed earth when properly mixed and cured, sits in the range of 5 to 20 megapascals depending on your soil and additive ratios. That is more than enough to carry a multi-story building. That is more than enough to stop a rifle round. And it costs a fraction of what poured concrete costs. A research overview published in Construction and Building Materials in 2023 reported that lime mortars using rice husk ash and silica fume reached over 16 megapascals of compressive strength at 28 days. That is 4 times the strength of lime mortar by itself. Another study reported durability improvements of up to 300% compared to standard Portland cement mixes when properly formulated pozzolanic binders were used. 300% more durable than the concrete in the foundation under your house right now. And the active ingredient in many of these test mixes is wood ash, brick dust, or rice husks, materials sitting in agricultural waste piles and abandoned brickyards in every country on Earth. There is also one more reason this formula is better for the planet that nobody in the cement business wants you thinking about. Cement production accounts for approximately 7% of all human carbon dioxide emissions globally. Around 4 billion metric tons of cement are produced every year. Every ton releases roughly half a ton of CO2 into the atmosphere. The lime pozzolan method requires far less heat to produce. The ash is already a waste product from burning. The dirt is inert. The carbon footprint of a rammed earth wall is a tiny fraction of the equivalent concrete structure. Despite the climate crisis, despite the cost advantage, despite the durability advantage that now has peer-reviewed scientific backing, you still cannot walk into a single major hardware store in North America and buy a bag of pozzolanic lime mortar marketed for rammed earth construction. You can buy quicklime. You can sometimes buy hydrated lime for masonry joints. You will never find them packaged and marketed for the purpose this video is describing. The market has been engineered to forget, and that forgotten knowledge is costing ordinary builders tens of thousands of dollars on every project, where a rammed earth wall would have done the job better and lasted longer. Now here is exactly how you build with this. Start with your soil selection, not topsoil. Topsoil is full of organic material that will rot over time and compromise the wall. You want subsoil, the layer right below the topsoil, ideally with a clay content between 15 and 30%. The rest should be a mix of sand, silt, and small gravel. There's a simple field test you can do right now with a handful of dirt from your property. Wet it slightly, squeeze it into a ball, and try to break it apart. If it shatters immediately, your clay content is too low. If it deforms like soft putty without breaking, your clay content is too high. If it breaks with a clean, solid fracture and holds its shape, your soil is ready for rammed earth. Most rural land has perfectly usable subsoil within 3 feet of the surface. Next, your ash. If you have a wood stove, a fire pit, or access to any farm that burns brush regularly, you already have your pozzolan sitting in a pile somewhere. Sift the ash through a standard window screen to remove unburned chunks and charcoal. You want fine uniform powder, gray to white in color. The whiter the ash, the better the pozzolanic activity, because complete combustion produces the most reactive silica. If you do not have wood ash available, crushed fired clay brick works exactly the same way. Gather broken bricks from any demolition site and pulverize them in a feed grinder or with a hammer until they pass through the same screen. Your lime comes from any agricultural supply or masonry yard. A 50-pound bag costs between $8 and $15. Look for Type S hydrated lime, which is fully slaked and safe to work with. If you can source quicklime, the slaking process gives you a hotter and more reactive product, but Type S works for almost every application and is far safer to handle without special equipment. The basic mix ratio by volume is roughly 1 part hydrated lime to 1 or 2 parts ash or brick dust to 7 to 10 parts subsoil. Add water gradually until the mix holds together when squeezed but does not stick to your hands. Aim for what builders call optimum moisture content, around 10 to 15% water by weight. The mix should look damp, not wet. Think coarse breadcrumbs that clump when pressed. Build simple wooden formwork from 2 parallel boards set 18 to 24 inches apart and braced firmly so they cannot push outward under pressure. Plywood works for shorter walls. Reinforced steel framing is better for anything taller than 4 feet. Pour your mix into the form in lifts of about 6 inches at a time and ram each lift with a hand tamper or a pneumatic tamper until the soil compacts to roughly half its original loose volume. You will know when a layer is fully compacted because the sound changes from a dull thud to a sharp ringing tone. That is not a guess. That is your quality indicator. Lift by lift until the form is full. Let it sit for 24 hours. Strip the form. Move to the next section. For the first week, mist the surface with water once each day. Pozzolanic reactions need moisture to keep going during early curing. After the first month, the wall has reached most of its handling strength. After 90 days, it has reached most of its design strength. After a year, it is still hardening, slowly, quietly, for decades. Walls built this way in the late 19th century across southern France, northern Spain, and rural China are still standing today. No maintenance, no rebar, no chemical sealants. A 2-foot thick rammed earth wall, properly mixed and cured, will stop a rifle round at typical hunting distances. The mass and density absorb and disperse impact energy in a way that wood frame and even standard cinder block simply cannot match. These walls insulate against heat in summer and hold warmth through winter with thermal mass values that crush conventional construction metrics. They are fireproof. They do not rot. They do not attract termites. They do not off-gas synthetic chemicals into the air your family is breathing. I will give you the honest limitations too, because no one else will be straight with you about them. Rammed earth is heavy. A 2-foot section of finished wall weighs roughly 200 pounds per square foot of face area. Your foundation must be designed for that load from the beginning. Drainage is critical. Earth walls do not tolerate sitting water at their base. You need a proper stem wall of stone or concrete to lift the rammed earth above grade and keep moisture away from the base. The roof overhang needs to be wide enough to protect the face of the wall from horizontal rain, and cure times are long. If you need a building finished in a week, this is not your method. But if you need a building that will outlive you, your children, and very likely your grandchildren, nothing else you can build with a comparable budget comes close. One safety note before anything else: quicklime and even hydrated lime are caustic materials. Wear gloves, wear eye protection, wear a respirator when you are handling dry powder. Lime burns happen fast when you get careless, and they are not minor injuries. So here is where we land. The wall that the Byzantine builders raised against the Persians, against the Avars, against the Arabs, against the Vikings, against the Bulgars, against the Crusaders, against 53 straight days of bombardment from the most powerful cannon the medieval world had ever produced, was built from dirt and ash and lime, the same material sitting within 20 feet of where you are right now, the same chemistry that builders at Jericho figured out before anyone had invented the wheel. The same self-healing reactions that MIT laboratories rediscovered in 2023 and described as miraculous in peer-reviewed scientific journals. None of this is new, none of it is exotic, none of it is patentable, and none of it is being sold to you precisely because nothing about it generates a recurring revenue stream for an industry worth close to $2 trillion. Your great-great-grandfather, if he came from rural Europe, rural Asia, rural Africa, or rural pre-industrial America, almost certainly knew some version of this. The recipes lived in family workshops and village memory, passed from father to son to grandson until one generation walked into a hardware store, saw a bag of Portland cement marketed as the modern solution, and forgot to ask the old men what they already knew. That is how knowledge disappears. Not through banning, not through burning, through a marketing budget and a generation that stopped listening. But the chemistry never forgot. Every time someone burns brush in a fire pit, the pozzolan is sitting right there in the ash. Every time it rains on a clay bank, the binder is already in the mud. Every time a homeowner stares at a $20,000 quote for a poured concrete retaining wall, the formula that would do the job better for 1/10 of the cost is sitting in 3 buckets at their feet. This channel exists to put that knowledge back where it belongs, in your hands. Right now, I need you to do something. If this opened up something for you, hit the subscribe button. Share this video with someone who is about to spend serious money on a concrete project. Drop a comment below and tell me where you are watching from and whether you would actually try this on your own property. Your comments help this video reach more people who need to see it, and it keeps this channel doing exactly what it was built to do. We are just getting started. The next vault coming to this channel is going to dig into something that every household in America already throws away every week and could be using right now to turn rainwater into a clean drinking supply. The method is older than the industrial era, it costs almost nothing, and microbiologists have confirmed it pulls out over 99% of pathogens using nothing but natural materials. If you are subscribed, it will find you. If you are not, you will miss it like most of the people who need it most. Tap subscribe, tap the bell, and I will see you in the next vault.